Good day, guys. Welcome to the Math 2272 channel. So, the aim of this course is to discuss each topic in mathematics for secondary school level and from A level and 100 level university students. So, today we are going to be discussing set theory, our first topic in this course. So, in set theory, we'll start by defining what a set is. A set is a collection of different things. What this means is when we group a kind of object together, we can call it what set. What this means is if I say a set of farm tools, this include cutlass, hoe, basket, and so on. So these are sets. This is a set. So it's a collection of objects. So typically in math here, we are going to be talking about objects that are typically mathematical. So that is the member of our set in this course are mathematical objects. What we mean is we are going to be grouping some mathematical symbols, lines, geometrical shapes, variables, and other type of mathematical objects that we can think of. So, and this set, we can divide it into two. Generally, we can just divide them into two parts, which we term as finite set and infinite set. When we say something is finite, it means, or we just say finite, as some people will pronounce. When we say finite, it means it is actually countable. This set is something we can just deduce the number of the members inside the set. Each member of a set is what we call an element. When we say an element in this topic, we don't mean hydrogen, nitrogen, helium, and so on. We mean just the member of a particular set. So when we say a finite set or a finite set, this means a set that is countable. For example, if I say set of numbers that are even between 1 to 10. An example, set of even numbers from 1 to 10. So this is basically a finite set. So why is it finite? Because set of even number between 1 to 10 are basically countable. So in set, to represent a set, we use equally brackets like this. So now set of even number from 1 to 10. From 1 to 10, we have 2, 4, 6, 8, and 10. So this is a finite set because the number of elements inside the set is known. So 2, 4, 6, 8, 10, that is basically 5 elements of this particular set. So let's go again. Then we have infinite set. So when the number of elements in a set is unknown, the set is said to be infinite. So what type of set is actually infinite? When we say infinite set, the number of elements inside this particular set is unknown. And it's unknown meaning it's not something we can basically deduce. For example, if I say set of all positive integers, all positive integers. So set of all positive integers is not something we can actually know where it ends. So we can say from 1, 2, 3, and so on. We won't know where this ends. This is why we call this infinite set. Then we talk of subset and superset. What are subset and superset? So first, let's consider two given sets A and B. Let's consider two given sets A and B. So in this case, A is our first set and B is our second set. If the set A consists of some or all elements of set B. Let me repeat that. If A consists of some or all elements of B, then A is said to be a subset of B. If A consists of sum of all elements of B, then we say A is a subset of B. What does this particularly mean? Let's say we have set B, which is a number from 1 to 10. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's stop here. So then set A is all even number from this 1 to 10 as we used before. So we'll say 2, 4, 6, 8, 10. So it means set A, set B. These are our two sets. Then all elements of set A is also in set B. In this case, we are going to say A is a subset of B. And when we say A is a subset of B, mathematically, we are going to denote this like this. Put a line under, then we'll put B. When we see this in math, it means A is a subset of B. So this is what this mathematical notation means. So A is a subset of B. Now, if the set A is a subset of B and there is at least one element in set B which is not in A, then the set A is called a proper subset of B. What do we mean by this statement? Let me repeat that. If the set A is a subset of B, just like we have here, set A is a subset of B, and there is at least one element in set B which is not in set A. For example, in this case, we have set B to be 1 to 10 and set A to be even number from 1 to 10, which means all odd number from 1 to 10 are not part of set A. So this means A is definitely a subset of B. But there is at least one element in set B which doesn't belong to set A. So since we have this particular condition, so there are elements in set B which are not in set A. It means set A is a proper subset of set B. So in this case, set A is a proper subset of set B. Thus, we can write this just as A, then B. We won't put this line under. When we put the line under, it basically means all elements of set A are what we have in set B, but in this case, not all. So we only have the subset sign there. So A is a proper subset of B. Then, in that case, in the opposite direction, that this same statement that we have here, the same statement that we have here, just like what we said now, that if at least one element in set B does not is not part of element in set A, it means we call A a proper subset of B. Then if we have to reverse this statement like a passive statement, we are going to say B is a superset of A. So superset is just like the opposite of this particular mathematical notation. Then next, then we talk of equality of set. When do we say two sets are equal? Two sets A and B are said to be equal if A is a subset of B and B is a subset of A. What does this mean? Let's say we have two sets A and B as we have been using. Let's say our set A, this time let's use letters. We have A, B, C, D, then E. Let's say this is our set A. And we have set B as well. Set B is also the same thing, A, B, C, D, and E. It means all elements in set B are present in set A, and all elements in set A are present in set B. Mathematically, we can say A is a subset of B, and also B is a subset of A. In this case, we are going to say set A is equals set B. I hope we get this particular part. Then we talk of the universal set, the unit set, and the empty set. These are like we are discussing the terminologies that we use in set. So universal set, the unit set, and empty set are basically another terminologies that we use in set. When we say universal set in set, we are going to be using symbol that resemble U, or sometimes they use something that resemble this notation here. So a set which consists of only one element is called a unit set. But a set which contain all possible elements under consideration is known as the universal set. For example, let's say I'm using a set A. Now, let's say the first set consists of numbers from 1 to 20. So I'll consider this as my universal set. Then I have another set A, which is all even numbers, even number from that numbers that we are considering. Then B is odd number. So which means A is a subset of this universal set. All even number here are just from 2 to 20, and all odd number will start from 1, 3, 5, 7, 9, and so on up to 19. So A is a subset of universal set, B is a subset of this universal set, but the universal set is a set that consists of all elements in set A and all elements in set B. Even it might contain elements that are not present in both set A and set B. So we talk of the unit set. The unit set is a set that contains only one element. For example, if I have another set C and this set C consists of only A, so this is regarded as a unit set. Then an empty set is a set that doesn't contain any element. This means if I just have this is an empty set. Note that an element D or a set D with element 0 is not an empty set. So this is not empty because it contains the element 0. So 0 is considered something here. 0 doesn't mean nothing here. So basically 0 here is an element. Then let's talk of the cardinality of set. Let's consider a set A. This set A, let's say, is equals A, M, B, D, and H. Inside this set, there are 5 elements in the set. So the number of elements in a set is called its cardinality. So cardinality of a set is the number of elements inside that set. Since this set A has 5 elements, then the cardinal number is 5. So the cardinal number is denoted as n, then into bracket of A. So this is the cardinality of this set. So and this equals 5. I hope everyone get that. Now let's talk of the intersection and the union of a set. Let's consider 2 sets as we have been using as an example. So let's say we have a set X this time and another set Y. We have a set X which is all factors of 20, and let's say we have another set Y even numbers from 1 to 20. Okay, let's deduce what these two sets are. X is all factors of 20, and the factors of 20 are those number that we can get multiple of that can basically divide 20. Let's just say. So let's say the first one 1, 2, 1 is a basic factor of all numbers. Then 2, we have 4, then we have 5, then 10, then 20. That's all. So these are the elements of set X. Then set Y is even number from 1 to 20. So we have 2, 4, 6, 8, 10, 12, 14, 16, then 18, and 20. So we'll say intersection of a set. These are the members of set X and set Y. Then the intersection of this set will be those elements that are in both sets. Elements that are in set X and are also in set Y. For example, here we have 2, here we have 4, then we have 10, and we have 20. So these four numbers are the intersection of set X and Y, and mathematical notation, we are going to write this as X intersection Y. This symbol that look like N here is regarded as intersection. Then the set will be equals those numbers that are present in both sets. So we have 2, we have 4, we have 10, and we have 20. This is it. Then the union of a set is just the set of all elements that are present in both set X and set Y without making the repetition of an element twice. So which means X union Y. Union is a symbol that look like U here, but it's not U like this. It's just a curve symbol upward, and this is a curve downward. So I have this. If I want to write the union of these two sets, I'm just going to arrange just the number the way it is alphabet numerically. So the first number here is 1, then the next one is 2, then followed by 4. I don't have to repeat each number multiple times. So I have 1, 2, 4, then followed by 5 upward from set X, then 6 from set Y, then I have 8 from set Y, then 10 from set X, then 12 from set Y numerically, then 14 from set Y, then I have 16 from set Y, 18, then 20. So this is the union of set X and Y, and this is the intersection of both sets. So now let's have some examples to deal with here. The first example we have here says, given that U is equals to all the days in a week, set B is all the days in the week whose letter begin with S. And the first question says should list all the elements of set U, which is basically the universal set in this case. So 2 list the members of B, 3 list the member of B prime. We haven't talked about that yet, but we are going to talk about it now. So then 4, what is the cardinality of set B, and 5, what is the cardinality of set B prime. And B prime here is basically known as the complement of set B. We're going to talk of that now. So complement of set B. So let's have this. So given that the universal set is all the days in a week, so all the days in the week, we're just going to use the individual letters so that we can identify them, or maybe 3 letters. So I have set U. So we have to list all the elements of U. So I have this, the set of the first day of the week, which is the Sunday, then followed by Monday, followed by the Tuesday, followed by the Wednesday, then the Thursday, then Friday, then the Saturday. Then that is the solution of the first question that we have here. The second question says we should list the member of B. Now what's set B? 2. So I have set B will be equals to, what's set B? All days in the week whose letter begin with S, and basically those are only Saturdays and Sunday. So I will have here Sunday, then Saturday. That's it. So this is the solution to that. Then 3, I have list the member of B prime, and B prime is what we call the complement of set B. And what is the complement of a set? The complement of a set is all the elements inside the universal set but not in that set. Listen to that again. All the elements inside the universal set and not in that set. For example, in this set, in set B, we have Sunday and Saturday. So which means our complement of set B will be all the elements in the universal set except Sunday and Saturday. So I'll have Monday, Tuesday, Wednesday, Thursday, and Friday. So this is the complement of set B. Then next I have for what is the cardinality of B, which is n of B. So this is how many elements are inside set B. That is just 2. So I'll put 2 here. And lastly, I have what is the cardinality of the complement of B. So I'll be having n of B complement. So in some cases, we write this as B prime. We just call it B complement, or we just write B and to the superscript of small c at the top here. So it's basically the same thing. So here we just count how many elements are there in that. I have 1, 2, 3, 4, then 5. So this is 5, and that's all about the question. The next question we are going to deal with is we have another question here, which is basically like that first question that we have there. So the question says, if the universal set is all the months in a year, and set A is all the months in the year that begin with letter J, and set B is all the months in the year that end with letter R, that ends or ending with letter R, then we are supposed to list all the members of the universal set. So we are just going to represent that with maybe 3 or 4 letters. So I have 1. So this is universal set, all the months in a year. So we're just going to count that. I have the January, then the February, and I have the March. So MAR for that. Then we have the April. Let's going to write that in full, or APR. Let's just say. Then we have the May. Then we have the June. Then we have the July. Then August, just say AUG. Then the September, I'll just write set for that. Then October, write Oct for that. Then November, just say Nov for that. Then December, just gonna say Dec for that. So next thing we're gonna do is we're done with listing the universal set. So we're gonna list the second set, which is member of A. So I'm going to use another color for that. So green. So I have set A equals all the months in the year that begin with letter J. So here we have January. So I'll just say January here. Then we have the June. Then we have the July. Then this is all. Then next we have three. I'm using that color for that as well. So blue. So all members of B, all the months in the year ending with the letter R. So since we didn't write this the letters in full, let's just let's go back to this place so that let's just put it here like this. So I have the January, I have the February, so I have the March, I have the April, I have the May, I have the June, July, August, September, October, November, then December. So how many of these are ending in R? So we have from September to this place. So that's like 4. So we'll go back to that page. So we're just going to say set B is, I have the September, October, November, then December. So this is all for the question. Then for the question says we should find the cardinality of A plus the cardinality of B complement. So we're just going to say cardinality of set A. How many elements is inside set A? That is 3. 1, 2, 3. So we're going to say 3. Then plus the cardinality of set B complement. So we're going to say how many elements are inside the universal set but not in B. So that is the B complement, right? So all elements that are not in B but inside universal set. So we're just going to cancel all this out from the universal set and count the rest. For half January, February, 1, 2, 3, 4, 5, 6, 7, 8. So that's 3 plus 8, and that's going to give us 11. So this is another question right here. So this question says the subsets A, B, and C of a universal set are defined as follows. So I have the set A to be MAPE. So this is like MAPE or something. So MAPE. So set B is AEIO. You guys pretty much vowels, right? So then set C is LMNOPQRSTU. So the question says list the elements of the following set. So first we have to list A union B. So find the union of A and B. How are we going to do that? We're just to combine the elements of A and element of B. That's all. So we can just consider that alphabetically since these are alphabets. So in set A and set B, I have element A. So I'm just going to put A first. So then followed, I have elements. So I have this already here. So I have element E. So I'm just going to list element E next. Then I have this. So pretty much followed by element I, right? So I'm just going to say element I. So then follow, I'll just say element M. Then element O. Element P. Then element U. So these are all the elements inside set A and set B combined, and that is A union B. That's all. So then 2, we have A union C. So I have A union C here. No, C. A union C. So which is pretty much element inside A and C combined. So let's look at that. Inside A, we have M. Inside C, we also have M. So we're not going to repeat that. So A is not there in element C. P is there in element C, but E is not there in element C. So we're just going to say this is element of, we have A, which is in element A in set A, then E, which is in set A as well, then and the rest of set C. So which is L, M, N, O, P, Q, R, S, T, and U. And this is it. And the third question here says we should list the element of A union, then into bracket B union C. When you have a problem like this, the first thing you should do is do the bracket first. So we're going to do B union C first. So we're going to find the union of elements B and sets B and C. So set B and C, you can combine this. We have A, E, I, O, U. The only elements that are inside C and B is O and U. So the rest of element A, element B, will have A, comma, E, comma, I, and the rest of element C. So that's going to be L, M, N, O, P, Q, R, S, T, and U. So this is B union C. So we're not going to find A union B union C in bracket. So this is B union C right here. We're going to combine B union C with A. And what is A? A is MAPE. And if we observe element A very well, we observe that M is already in this B union C. A is already in this B union C. P is already in this B union C. And E is already in this B union C, which is pretty much means that B union C is the same thing as A union B union C. So we are just going to list exactly the same element again. So A, E, I, L, M, N, O, P, Q, R, S, T, and U. So let's try another problem right here. So these are pretty much numbers. So I have a question here which says element A is 2468 and B is 2379. Then C says we're going to find C first. C says X is a member of C, and that is denoted by 3 less than X, X less than 9. So that pretty much means 3 less than X. Just interpret that quietly. 3 less than X. 3 is less than X. And what does that mean? X is greater than 3, which means we're going to start from 4. So start from 4 to X less than 9, which means we're going to stop at 8. So I have 4, 5, 6, 7, then 8. So then these are subset of the universal set, and let's bring that out. We have the universal set to be 2, 3, 4, 5, 6, 7, 8, then 9. The question says we should find A. We have A intersection B intersection C. So first we'll find B intersection C in that bracket. So what is B intersection C? Elements that are present in both B and C. So we check that. In B we have 2. In C we don't have 2. So we have 3. Then 7, 9. Then the element that are present in B and C is pretty much only 7. Right? Yeah, 7. So only 7. So we're just going to say this is 7. So the next we'll find A intersection B intersection C. So is there any intersection in this B intersection C and set A? What is set A? Set A is 2, 4, 6, 8. and set B intersection C is 7, so there is no intersection, so we are just going to write this, and this means empty or null set, and that's all. B, we go to B. B says we should find A union B. That's pretty much wide. Let's write that. So we have A union B intersection B union C. So we do it one after the other, like we find A union B first. So this is A union B, which is combination of set of elements in A and in B. In A we have 2, in B we have 2, so we are just now take 1, 2. So in B we have 3. So let's go back to that. In B we have 3. In A we have 4. In A we have 6. In B we have 7. In A we have 8, and in B we have 9. So that is A union B. So we are going to find B union C in the same way. So we have B union C. So B union C is element in B and in C. So this is B. We have 2 in B, then 3 in B, then 4 in C, 5 in C, 6 in C, 7 in C and B, then 8 in C, then 9 in B. So this is it. So the next thing is we're going to find the intersection. Intersection is set of elements that are present here and also here. So let's pretty much change that and use white for that. So I will find A union B, then intersection of B union C. So this is equals, in A union B we have 2, 2 is common, 3 is common, 4 is common, 5 is not common, 6 is common, 7 is common, 8 is common, and 9 is common. All those elements that are common, we're going to put it down. So we have 2, 3, we have 4, we have 6, we have 7, we have 8, and we have 9. That's our solution to this problem. Let's try another problem. Let's see if we have another problem. Wow.